Okay, so inelastic collisions, slightly different than elastic. Big things you should note about inelastic: kinetic energy is not conserved in the collision. This means that the initial kinetic energy, some of it is converted to kinetic energy at the end, but there also is sound and heat and deformation of the objects themselves. Okay, so for inelastic, kinetic energy is not conserved. What this really means is that the objects stick together. Okay, so they move as one after the collision. Okay, so let's do an example. Let's say that we have mass A and mass B. Mass B is going to initially start at rest. Mass A is moving towards it at 3 meters a second. Okay, mass A has a mass of 1 kilogram, mass B is 2 kilograms. After the collision, they're going to stick together and move as one. So we don't know either of the final velocities. So to do this, we're going to start with our trusty momentum initial equals momentum final equation. At the beginning, only A is moving, so we only have an initial velocity of A. After the collision, these move together, so it's the momentum of A plus B because they're together. So we have mass of A, velocity initial of A, equals. Since it's one giant object, we have to do the total mass on this right side of the equation. So it's going to be mass A plus mass B, all times the final velocity of both objects. Okay, so again, it's the total mass because they move as one object. To solve for final velocity, I'm going to divide both sides by what's in the parentheses. So I get the mass of A, velocity initial A, over ma plus mb. That's going to equal my final velocity. Okay, and so let's plug in some numbers. We get 1 times 3 over 1 plus 2. And nice and easy to do in your head, you get a final velocity of 1 meter a second. Okay, so again, the difference here is that they stick together, so we have a total mass at the end, right here, okay, times the final velocity, which is the same for both.